Hello, guys. Welcome to Ramta Solutions. Welcome to your vertical projectile motion past paper series. Today, the question that we are looking at is from the Gauteng province. This is the examination of June 2024. Of course, it is the provincial examination. So, as is a norm, we're going to read instructions. Of course, we're going to select few, which is probably 3. So, instruction 8 says, show all formulae and substitutions in all calculations. Instruction 9, round off your final numerical answers to a minimum of 2 decimal places. A further tip on this is that in the middle of your calculations, only round off to about 4 to 5 decimal places and only round off to 2 decimal places on your final numerical answer. Then, instruction 10, give brief motivations, discussions, and so on where required. Okay, so these are June examinations. Probably our projectile motion questions are in question 4 for sure. Okay, perfect. Now let's go. This is question 4. Now, let's see. A learner standing at the bottom of a building throws ball A. Okay, so let's now look at A. Vertically upwards at a speed of 11 meters per second. All right, so this one is at the bottom. So this one is at the bottom. The bottom we can say y0. Okay, and then let's see. And ball A reaches a maximum height t after 0.7 seconds. After 0.7 seconds. Okay, so after 0.72 seconds, by the way. A learner standing on the roof of a building throws ball B upwards. So initial velocity of ball B is unknown, but it's going upwards. The two balls meet at point T at the same time. Meet at T at the same time. All right? They meet at T at the same time, isn't it? At the same time. Of course, as shown in the diagram. What is the difference between free fall and projectile motion? There is no difference. They mean the same thing. Okay. There is no difference. They mean the same thing. There is no difference. They mean the same thing. Oh, sorry. There is no difference. I should say there is no difference. Period. They mean the same thing. They mean the same thing. Right? Perfect. Now, 4.2 says, by the way, guys, remember 1 mark, 1 minute. 4.2 says, calculate the time taken for ball A to reach the maximum height at T. So again, we're going to say these are vector calculations. So we're going to say upwards is positive. Okay, we're going to say upwards is positive. So we're looking for time taken. So we're going to say V sub F equals V sub I plus A delta T. Why? Because we know at maximum height, velocity is 0. What is the initial velocity? It is 11 meters per second upwards. So it's positive 11. Acceleration, because we said upwards is positive, it's going to be negative 9.8. Okay. So this will then be 1 point something. Delta T will be 1 point something. Let's see. We can say, if you like, 9.8 delta T equals 11. This step is not necessary, guys. Delta T is equal to 1 point, I don't know. 1 point, let's see. 11 divided by 9.8 is 1.12 seconds. It's 1.12 seconds. Okay. Ooh, let me charge quickly. And charge. Hello. Okay, thank you. Now, let's see. 4. This was 4.2.1. We are okay. Now 4.2.2, initial velocity of ball B. So before we get that, we can use final velocity. We can use maximum height because we know it's final velocity. But we need to know the time it takes ball B to reach maximum height. So time it takes B to reach maximum height T. What is it? Is 1,12 minus 0,72. It's 0,4 seconds. Let's confirm. 1,12 minus 0,72. Yes, it's 0,4 seconds. All right, it's 0,4 seconds. Now at T, so we'll say again, I will say upwards is positive. Right, I will say upwards is positive. So we will use the formula because we know final velocity is 0, meaning velocity at point T equals initial velocity plus A delta T. All right. So let's see. We said initial velocity is is 0, meaning velocity at point T is 0. What is the initial velocity? We do not know. Acceleration, we said upwards is positive. So it means it will be negative 9.8. And the time it took to reach maximum height was 0.4. So 0 equals V sub I minus 9.8 times 0.4. It's 3.92. So it's minus 3.92. Therefore, initial velocity is positive 3.92 meters per second. So the question says we must find initial velocity. So it means we must specify the direction. Because it's positive, it means it's upwards. All right? So it means it's upwards. Okay, perfect. Now 4.2.3, the height of the building. This is 6 marks, guys. 6 marks. So 6 marks, 6 minutes. Let's see. Height of the building. And check this out. We are already on about 7 minutes and we have done about 9 marks. We are on the right track. So here what we're going to do, we're going to distances traveled. So we're going to say distance traveled to reach maximum height. Distance traveled to reach maximum height. Okay, maximum height is T, right? We're going to use the formula. Again, upwards is positive. Upwards is positive. Then we're going to use the formula delta Y equals, we have initial velocity for both balls. So we're going to use this formula. Okay, we're going to use this formula. So for object A, we will say, what is the in place of delta Y, we will just simply say delta Y sub A. Initial velocity for object A, it was 11 meters per second going up. We said it took 1.12 seconds to reach maximum height. All right, 1.12 seconds, 1.12 seconds to reach maximum height. And acceleration, we said upwards is positive, so it's going to be negative. Again, the time is 1.12. Okay, square. So let's see, 11 times 1.12 minus 4.9 times 1.12 square, close. What do we get? We get 6,17344. I think I can leave it as 44 meters, isn't it? Perfect. Now, for object B, again, I'm going to say delta Y sub B equals, initial velocity was 3.92. Let me go back to confirm. Yes, it was 3.92. That was initial velocity of object B. It was 3.92. And the time, I think it was 0.4 seconds. Yeah, it was 0.4 seconds. You guys remember 1.12 minus 0.72. It was 0.4 plus half times negative 9.8, 0.4 square. That's it. 3.92 times 0.4 close minus 4.9 open, 0.4 square close. It is 0.784. So this is 0.784 meters. Now the question is saying, what is the height? Guys, I want you to see something here. Let me scroll down. I want you to see something here. So you will agree with me that delta y, delta y a plus delta, okay, let me just write these guys first. So this is point T, which is maximum height. So before that, you will agree with me that delta y a is basically delta y b plus height of the building. Do you guys agree? It is right. So we know this one was 6.17344 and this one is 0.784 plus the height. Therefore, we can say the height is 6.17344 minus 0.784. 6.17344 minus 0.784. I should have said previous answer minus answer. Okay. So what do we get? We get our answer as 5.39 meters. That is the height of the building. Okay, that is the height of the building. So far we have done questions that are worth 15 marks and we did them in less than 15 marks. So let's see. It seems the question is not done. Yep, let's go. Now, 4.3. The following position time graphs is given for the motion of the two balls A and B as described above. Study the graphs and answer the questions. Write down the value and unit for 4.3.1. X. What is X? X is point T. Point T was, if I recall, maximum height. Maximum height from the ground was 6.17 meters. Can you see it? Here is it. We got it using that one of ball A, 6.17 meters. So it's 6.17 meters. 4.3.2 Y. What is Y? Y is H, the height of the building. We just found it, 5.39, if my memory serves me well. Here is it, 5.39. It's 5.39. 4.3.3, they say we must look for Z. Where is Z? Z is the time. So Z is the time. When I look at it, the time when object B was released. Object B was released. So I'm going to say when B was released, it was released 0.72 seconds later. Right? 0.72 seconds later. Okay, perfect. Now 4.3.4 W. What is W? W will be time taken to reach maximum height. Okay, will be time taken to reach point T. Therefore, W is, I think it was the first question, 1.12. Let me confirm. 1.12 seconds. Indeed, it was 1.12 seconds. Okay, It was 1.12 seconds. 1.12 seconds. So this is how you solve your vertical projectile motion questions. Okay, guys? So this is it. And then see you next time. So bye bye.